A customer buys something. 4 things have to happen. Take the payment, reserve the stock, book the courier, tell the mainframe. Steps 1 and 2 succeed. Step 3 fails because the courier's API is having a day. In a single database, this is trivial. You roll back, and it is as though nothing happened. Here, you have already taken the customer's money and reserved stock in a warehouse. There is no rollback statement that reaches across a payment provider, a warehouse system, and a 40-year-old mainframe. The money is gone. It is really gone. The question of this episode is what you do about that. And the answer is not a technical trick, it is a change in what you think a transaction is. Someone will suggest two-phase commit, and it deserves a real answer rather than a sneer, because it does solve exactly this problem. A coordinator asks every participant to prepare, and if all say yes, it tells them all to commit. It works. The trouble is what it demands. Every participant must implement the protocol, which rules out the courier's REST API and probably your mainframe. Every participant must hold locks between prepare and commit. So a slow service makes everyone slow, and the coordinator is a single point whose failure leaves participants stuck, holding those locks, waiting for an answer that is not coming. That is acceptable inside one database cluster, across the internet, against systems you do not own. It is a way of coupling your availability to everyone else's worst day. So a Saga gives up on atomicity and buys something else. The process becomes a sequence of local transactions, each one committing on its own, immediately, releasing its locks. And for each step, you also define its compensation, the thing you do to undo it after the fact. Payment taken becomes payment refunded. Stock reserved becomes stock released. When step 3 fails, you do not roll back, because there is nothing to roll back to. You run the compensations for steps 2 and 1 in reverse, and the system arrives somewhere sensible. Crucially, that somewhere is not the past. The refund exists. It is on the customer's statement. You did not undo history, you added to it, and that difference is the whole pattern. And here's where Sagas stop being an engineering pattern and become a business conversation. Not every step has a clean compensation. You can refund a payment. You can release stock. You cannot unsend the email that told the customer their order shipped. You cannot unship the parcel that is on a van. So the design work is not writing the compensations. It is ordering the steps so that the irreversible ones happen last, once everything reversible has already succeeded. Take the money before you dispatch, not after. And for the genuinely irreversible, the compensation is a human process. Someone calls the customer. Writing that down as an explicit step, rather than pretending the code handles it, is the difference between a saga and a fantasy. 2 ways to wire it. Choreography. No central brain, each service listens for the previous event and emits its own. It is elegant, and it is beautifully decoupled. And with 3 steps, it is genuinely lovely. With 8, nobody in the building can tell you what the process does, because the process is not written anywhere. It is an emergent property of 8 services subscriptions, and you debug it by reading logs in 8 places at 2 in the morning. Orchestration. One component owns the sequence, calls each step, and handles the failures. It reintroduces a coupling everyone told you to avoid, and it is a single component that must not lose its mind. In exchange, the process is a thing you can open and read. For anything a regulator might ask about, or anything longer than about 4 steps, take the orchestrator. Being able to answer where is order 4471 stuck is worth more than architectural purity. So we can run a business process across services that were never designed to cooperate, and recover when part of it fails, which leaves the moment everything has been building towards. The new service is ready, and the traffic is still going to the mainframe. Next episode, moving it across at 1% at a time without anybody noticing. See you there.